Hello students, let's solve this paper is of session October-November 2024 and this is paper number 1. Let's start. The question number 1 is what are the SI base units for the moment of the force? Now what is moment of the force? Moment of force is defined as the product of force with perpendicular distance from the axis of rotation. Now, for the force, you can write mass into acceleration. For the mass, the units are kilogram. For the acceleration, it is meter per second square. And for the distance, again, you will write meter. So it will give you kilogram meter square per second square. So the option is D. Question number 2 says that which statement about vector quantities is correct? So what are the vector quantities? Vector quantities are the quantities which have magnitude as well as direction. Now, if you look at all these options, for option A, acceleration of free fall is a vector quantity because it has constant magnitude, but there is no mention of the direction. So this option is wrong. Temperature in degree centigrade is a vector quantity. It's wrong. Temperature is a scalar quantity. Time is a vector quantity. Again, this option is wrong. So the only option we are left with is option D. Now, in this option, he is saying that weight is a vector quantity, right? Because weight is a force and because it has a direction, right? So option D is correct option. Now look at this question number 3. In this question number 3, the density of the material of a rectangular box is determined by measuring the mass and the linear dimensions of the block. The list shows the results obtained together with their uncertainties. So these are the main values and these are the uncertainties that he is saying. And it is given that the density is calculated to be 2.50 gram per centimeter cube. Then you have to find the uncertainty in the density. Now we know that density is mass per unit volume. Okay. Now if you have to find the uncertainty in the density, now that can be density times uncertainty in mass with the uncertainty in the volume. Right? Now we know that volume is given by length into breadth into height. Now if we want to calculate the uncertainty in volume, so what we have to do? We have to do delta L by L, delta B by B, delta H by H. So from here you can calculate delta V by V. Now what is delta L? That is the uncertainty in delta L. So that is 0.01 divided by 5 plus uncertainty in breadth or width. So that is 0.01 divided by 2 plus 0.01, that is the uncertainty in height, and that is divided by 1. So that will give you this variation, relative variation or relative value in V. So if we solve it, we will get 0.002 plus 0.005 plus 0.01. Now if you add them, you will get 0.017, right? Now if you come here, if you substitute the value of the density, that is 2.50. Now this relative value of m, that is the mass, so the uncertainty is 0.1 divided by the exact value of mass is 25 gram plus this value we can substitute as 0.017. Now if we solve this value, 0.1 divided by 25, so that comes out to be 0.004 plus 0.017. Now if you further solve it, that is 2.50 and that comes out to be equal to 0.021. Now if you multiply it, you will get 0.0525. Now if we try to write up to 2 decimal places. So that comes out to be 0.05 gram per centimeter cube. So C is the answer. Now look at question number 4. In this question, he is asking us to have a reasonable estimate of the volume of one page from this examination paper. So assuming this examination paper is of A4 size. Now the length of the paper seems to be equal to 300 millimeters. The width of the paper is about 200 millimeters. And the thickness of the paper is about 0.1 millimeter. Now, if you multiply all three, you will get 6,000 millimeter cube. So that is a rough estimate of the volume of the page. In this question number 5, it is given that an object is projected from the horizontal ground at a velocity of magnitude u and at an angle theta to the horizontal. It hits the ground at a time t after it is projected, means this time is the time of flight. Assume air resistance is negligible. Then you have to tell that which statement does not describe the motion of this object. So we have to check all the options. A, the horizontal component of the object's velocity is constant and has the value u cos theta. So that is right. So if this is u cos theta, so that is constant because there is no force along the horizontal direction. So this is not our option because we have to state which does not describe the motion. The horizontal distance traveled by the object is t times u cos theta, right? That is the horizontal range. So again, because this option is right, so this is describing the motion. So this is not our right choice here in the question. The time taken for the object to reach the maximum height is t by 2. So this option is not the valid option here, because this option is right and we have to find does not describe, because it is describing for this half time the particle will be at the maximum height. Now we are only left with option D, in which he is saying that the vertical component of the object's velocity is constant and has value u sine theta. Now this part is right, but this part is wrong. The value of velocity will change because acceleration is in the downward direction, and that is g, and that will reduce the magnitude of the velocity, it means the vertical component. So this option is the corresponding option as per the question, that this statement does not describe the motion of the object. Now in question 6, it is given that a person traveling on a motorway a distance of 200 kilometers travels the first 90 kilometer at an average speed of 80 kilometer per hour. So that is the total distance of 200 kilometers. And the first 90 kilometers he is covering with an average speed of 80 kilometer per hour. Okay, so the corresponding time he is taking to complete the first part of the motion is say t1, and if we solve it, so we will get 1.125 hours, right? Now he is asking that which average speed must be obtained for the rest of the journey. So how much distance is left to be covered? That is 110 kilometers. So he is asking that the total time taken is 2 hours and 0 minutes. So what is the average speed of the remaining journey? So the average speed of the remaining journey will be equal to the remaining distance, that is 110 kilometers, and the remaining time, because the total time is 1.125 hours. So if you subtract that value of 1.125 hours from 2, because that will be the remaining time for 110 kilometers, so that time is equal to 0.855 hours. Okay, now if you solve it, you will get 125.714. So that is approximately 126 kilometers per hour. So option is D. Question number 7. In this question, it is said that a car of mass 1200 kilogram has a momentum of 18,000 kilogram meter per second. So what's the kinetic energy of the car? So it's a very simple question. So kinetic energy is related to momentum by this formula, p square by 2m. P is the momentum, m is the mass of the particle. So the momentum is 18 into 10 to the power 3. So you'll square it to mass. Mass is 1200 kilograms. So if you solve it, you will get 13.5 into 10 to the power 3 joule. So as per the option, it is 135, 13.5 into 10 to the power 4 joule. So if you solve this, so you will get 135 kilojoule. So C is the option. Now this is a very interesting question, question number 8. In this question, it is given that a ladder is positioned on icy, means frictionless ground. So this ground is frictionless, right? And is leaned against a rough wall. So the wall is rough. Okay. At the instant of release, it begins to slide, right? So which diagram shows the direction of the force P, W, and R acting on the ladder as it slides? Okay. Now when it comes to this end, that is touching the ground, now there is no horizontal force that is acting along the ground. So only force that will act is the normal reaction. So this representation is right. Now when we come to the weight that will act through the center of mass of the object, that is vertically downward, that is also right. But when it comes to the point of contact of the ladder with the wall, now here we are given with that the wall is rough. So one force, that is the force of friction, that will act in this direction, and the another force is the normal force that is perpendicular to the supporting surface. So here we have two forces. One is the normal reaction and another is the force of friction. Now if we take the resultant of these two, so that will be the contact force which this point of contact is making with the wall. So first option is not right, because here P is the force at the point of contact. So the direction of this contact force is not along the horizontal, it is at certain angle with the horizontal. So if we carefully look at all the four options, so option B is the correct option. So this option B is the correct option. See, here the force P, that is the contact force, that is the resultant of two forces, means the frictional force and the normal reaction force at this point. So B is the correct option. In question 9, we have a parachute that is dropped from a bridge and falls vertically through the air. The graph shows the distance traveled by the parachute against time. Okay, so it is distance traveled and that is time. Which region of the graph shows when the parachute is at terminal velocity? Terminal velocity is that constant velocity at which a particle will fall such that the upthrust, drag force, and the weight will balance each other such that their net sum is 0. So in such a situation, the terminal velocity is a constant velocity. So this is a distance time graph, and here we have to look for the situation where the velocity is constant. So for that we have to look for the slope, and for this region B, from here to here, you can say that this is a straight line. Straight line means the slope is constant. So for the region B, we have a situation for the terminal velocity. So option is B. Now in this question 10th, it is given that there is an elevator that consists of a passenger car supported by a cable that runs over a light frictionless pulley to counterbalance. The counterbalance falls as the passenger car rises. So this is the arrangement given. So here in this situation, the masses of all the three, passenger car, counterbalance, and the passenger, are given. So the weight of the counterbalance is 640. So the corresponding force that is acting on the counterbalance is 6400 newtons. Now this passenger car and passenger, their combined mass is 520 and 80. So that leads to 600 kilograms, and the force acting here will be 6000 Newton. Okay. Now you have to calculate the acceleration of the car when carrying just one passenger and when the pulley is free to rotate. Now, in order to calculate the acceleration of the system, what we have to do, we have to look for the net force. So the net force is 6400 minus 6000 divided by, what is the mass of the system? Mass of the system is 600 plus 640, 600 plus 640. So that will yield 400 divided by 1240, right? So if you solve it, you will get 0.32 meter per second square. So the option B is the correct option. So basically, this question is the question of Atwood machine where two masses are moving over a frictionless pulley. Question number 11 says we have a stationary ball, means the initial velocity 0 of mass m is hit by a bat. The ball leaves the bat with a velocity v. The bat is in contact with the ball for a short interval of time delta t. What is the average force of the bat on the ball? Okay, so in order to calculate the average force, we have to check that what is the change in momentum the bat has created for the ball and in what time it has created. So basically we have to apply Newton's second law of motion. So the change in momentum for the ball is final momentum minus initial momentum is 0 because ball was at rest, and the corresponding time interval in which this change in momentum has been created is delta t. So the average force is mv by delta t. So the correct option is option B. Now in this question number 12, it is given that we have a disk of mass m that is moving across a horizontal frictionless surface with constant velocity u. So this is the mass and this is the constant velocity with which it is moving. It collides with a stationary disk of mass 4m. This is the stationary disk, means its initial velocity is 0 and its initial momentum is also 0. Its initial momentum is mu. Okay, the diagram shows the view from above of the motion of two disks before and after the collision. So this is the situation before collision, this is the situation after collision. And we know it very well that whenever we have to face the situations of the collision, momentum will always remains conserved, and if it's an elastic collision, the kinetic energy will also remains conserved. So in the beginning I have just written that these are the momentums of these particles. Now what he is asking us to calculate what is the initial velocity u of the disk of mass m. We have to calculate this. Now look at the final situation after the collision situation. As I am saying that the momentum will remain conserved, so let's resolve this situation in two dimension because the particles are moving in two dimension. And also you can observe that this is not head-on collision, its center is below the center of this mass, so definitely they will move at certain angles after the collision, and that angle is given 45 degree. Now if you want to calculate the momentum of this particle, so that is 4m mass times velocity. Now its component in this direction is 4m cos of 45 degree. Similarly for this is 4mv. So its momentum is 4mv and its component in this direction is 4mv cos 45 degree. Similarly, if we in the vertical direction, it is 4mv sine of 45 degree, and in this direction the value is 4m sine 45 degree, right? Now in this situation there is no momentum initial momentum along y-axis is 0. So the final momentum along y-axis must also be equal to 0. Now if you look at the momentum along the y-axis, so that will give us 4m sine 45 degrees 1 by root 2 and minus 4mv sine 45 degrees 1 by root 2, and that is 0. So I have put this minus sign because it is acting in the downward direction. So if we solve this, so what we will get, v, that is equal to 1 meter per second. So firstly we have calculated this value of v, so that we are getting 1 meter per second, right? Now the change in momentum for x-axis. So the initial momentum along x-axis is m into u, and the final momentum along x-axis is 4m. Cos 45 degree is 1 by root 2. So this part, then we have to write this part, that is 4m v. The value of v is 1 cos 45 degrees, this. So what we can write? We can write under root 2 4m. So that is the final momentum, and in order to conserve the momentum, we will write the equation mu, that is 4 root 2 m. M and m would get cancelled, so u will be equal to 4 root 2. So 4 root 2 is 1.414, and if we multiply it, we will get this answer, 5.7 meter per second. So D is the correct option. So this question was purely based on the conservation of momentum. So in question number 13, it is given that there is an object that is dropped from rest on earth from a height 2 meter. The same object is dropped from rest on the moon from twice the height, means 4 meters. Okay, the acceleration of free fall on the moon is approximately 16% of the value on the earth. So if the value on the earth is g, so then value on the moon will be 0.16 g. Assume that there are no resistive forces acting on the object, so then you have to calculate the value of this ratio. What is this ratio? The speed of the object just before hitting the surface on the earth to the speed of the object just before hitting the surface on the moon. So we know that for the free fall, the speed with which the particle will hit the ground will be equal to root 2gh, right? So for the earth, we will write VE, and for the moon we will write VM. And if we use this formula, so what we can write? So this ratio will be G on earth to the G on moon times H on earth to the H on moon. So if we put the values GE by GM, so that is 1 divided by 0.16, and height on the earth is 2 and the height on the moon is 4. So that is equal to 1 divided by 0.32, or you have 100 divided by 32 under the root. So if we solve this, we will get 1.767, and approximately if we try to write in two significant figures, so that is 1.8, right? So the correct option is option A. In question number 14, he is asking that the graph shows how velocity v varies with time for a bungee jumper. At which point is the bungee jumper momentarily at rest, means velocity has to be 0, and at which point does she have zero acceleration? Zero acceleration means this is a velocity time graph. So for the interval when the acceleration is 0, acceleration is 0 means the slope is 0. So the slope is 0 at this point Q. So the tangential line at this curve is parallel to this time axis. So the acceleration is 0 here and the velocity is 0 at point R. So if you look at the combination, so the jumper is at rest when it is at R, and the jumper with 0 acceleration is the point Q. So the correct option is option C. Question number 15. A solid sphere which is less dense than water is held completely immersed in water a few meters below the surface. The density of the water is uniform. The sphere is released. Immediately after the release, the sphere rises. Which row describes the change in the magnitudes of the upthrust on the sphere and the resultant force? Look at this, resultant force on the sphere as it rises. So first we will look for the upthrust. So for the upthrust, we know that that is equal to volume into density of the fluid into G. Now the volume, because it is completely submerged, so the volume displaced, volume of the fluid displaced by this sphere will remain constant. Density of the fluid, he has given that this is also constant. See, density of the water is uniform, and G, that is also constant. So upthrust is constant. So definitely option C and D are not possible. So there are only two options left, A and B. Now we have to look for the resultant force. Now look at this figure. What are the forces acting on it? This is mg, weight, so that will remain constant. Upthrust, that is V, density of fluid into G, that is also constant. Now for a given instant, if it is moving up, so the drag force will act in the downward direction, and that drag force is basically 6 pi eta rv. So basically this drag force is proportional to velocity. So after the release, it will gain the velocity, and due to this gain in velocity, this drag force will increase. So when this drag force will increase, this velocity will reach a constant value, right? Constant value means the net sum of force will finally be zero at that situation. Means at the terminal velocity situation, the net sum of force will become zero. Means the resultant force on the sphere will decrease. So the correct option is option A. Now this is a very interesting question on the situation of equilibrium. And which equilibrium? Rotational equilibrium. So here we have a uniform bar of 200 Newton. So the weight is acting through its center. It has length 4 meter, it is given. Is freely hinged on a wall at one point, this point, at one end here. The bar is horizontal and is held in equilibrium by a cable attached to at a distance 0.50 meter from the other end. The cable is at an angle of 35 degree to the horizontal. So you have to calculate the tension in the cable. So if we look at this tension, so it has one component in this direction, that is T cos 35 degree. And there is another component perpendicular to the rod, that is T sin 35 degree, right? Now for this point O, this force T sin 45 degree is producing the torque in the clockwise sense, and for this 200 Newton, it is producing a torque in the anti-clockwise sense. And because it is in equilibrium, so the sum of torques about point O will be equal to 0. So we can write T sin 35 degree and its perpendicular distance from the point of rotation, because it is 0.50 and this is 4, so the remaining is 3.5 meters. It is equal to the torque due to 200 Newton and the distance of this 200 Newton force from the point of rotation is 2 meters. So this is T 400 divided by 3.5. Sin 35 degrees is approximately 0.6. If you solve this, you will finally get 200.501, approximately 200 Newton. So the right option is option C. Question number 7. The diagrams all show a pair of equal forces acting on a meter rule. Which diagram shows forces that provide a couple and a zero resultant force? So for zero resultant force, the force must be acting in the opposite direction. So D is not a possibility. So D is not a possibility, and also A is not a possibility, because here the forces are acting in the same direction. So we are left with B and C. Now if you look at C, these two forces are acting in opposite direction. So this force will create an anti-clockwise torque, and this force will create a clockwise torque, and both are equal. So this situation cannot provide us couple, so this is not the option. So only option left is option B. So about this point, this is producing an anti-clockwise torque, and this is clockwise torque because this distance is say 2a, so this torque is more than this. So there is a net turning effect here, and also the net sum of force is 0 here. So the correct option is option B. 18th question. A ball of mass m is thrown up to the height h in air with an initial velocity v as shown. Air resistance is negligible. The acceleration of free fall is g. What is the total work done by the gravitational force on the ball during its flight from P to Q? Now, if you look at these points P and Q, you can say that the displacement along the vertical direction. So what is the displacement along the vertical direction? The displacement is 0 because both of the points are on the level ground. So we know that work done equals force times displacement, yet the force is acting on the particle, but the displacement has become 0, so work done is 0. So the correct option is option A. So in question 19th, we have a spring or spring constant 30 Newton per meter that is suspended vertically from its top. The spring obeys Hooke's law. Okay. Initially, the spring is not compressed and not stressed, means it is in its natural length. We have a mass of half kilogram that is attached to the bottom of the spring. The mass is released from rest and falls. Frictional effects are negligible. In the motion that follows, what is the maximum extension of the spring? So here we have to use work energy theorem. So what the work energy theorem says, that work done by all the forces equals to change in kinetic energy. So what are the work done here? Work done by gravitational force plus work done by the spring force, and that is equal to change in kinetic energy. So when you have released the mass, its initial velocity is 0, and at the bottom, when it reaches to its maximum extension, again the final speed is 0, so the change in kinetic energy is 0. Now you have to only look for the work done by the gravity and work done by the spring force. Now when the object is coming down, having mass m, it is coming down, so work done by the gravity is positive, so we will write that this is mgh maximum c. And the work done by the spring force, as the spring is extending, the spring force will act in the upward direction. This spring force is variable, right, and it will act in the upward direction, and the particle is moving down. So the work done by the spring force will be negative, and we know that it is equal to half k h max square, right, and that is equal to 0. So if we solve it, we will get h max, that is equal to 2mg divided by k. So if you substitute the values, 2 mass of the particle is half kilogram, g is 10 divided by k, that is 30, so that is 1 by 3. So if you write the final answer, that is D, 0.033 meters. For question number 20, we have a wire that has an original length L, cross-sectional area A. A tensile force is applied to the wire which causes it to have an extension X. The wire obeys Hooke's law. What is an expression for the Young's modulus of the material from which the wire is made? So we know that the Young's modulus is the ratio of stress by strain The stress is the stretching force, right? The tensile force divided by the area of the cross section. And the strain is change in length. The change in length means the extension, that is x, divided by the original length, right? Or simply you can write y equals to force per unit area divided by strain. So if we look at the options, we will get option B as the correct option. Now this is question 21. A wire is stretched by a gradually increasing force. Okay, the force extension graph for the wire is shown. So this is force and this is extension. So which statement must be correct? So we have to find which statement is correct. So if we look at the four options, point Q is the elastic limit. No, this is wrong. This is the limit of proportionality. Point R is the limit of proportionality. No, it is the elastic limit. The area under the graph P to S is the elastic potential energy stored in the wire. No, this is again wrong. So what is this? What is this area? So basically this area is the work done in stretching the wire. So the area under the force extension curve is basically the work done. So you will get the work done in stretching the wire. Question number 22. A spring has an unstretched length of 0.30 meter and a spring constant of 400 Newton per meter. An object is suspended from the spring and the spring is deformed within its limits of proportionality. The new length of the spring is 0.5. You have to calculate the elastic potential energy that is stored in the spring. So we know that the elastic potential energy is half K square of the extension in the spring. So this is half, spring constant is 400 and the extension in the spring is 0.20 meters and square of that. So if we solve it, we will get 8 joule. So the answer is A. Here in this question 23, we are given with a wire that consists of 3 meter length of metal X to 1 meter length of metal Y. The cross-sectional area of the wire is uniform, assuming it is same, and simultaneously then a load hung from the wire causes metal X to extend by 1.5 millimeter. So that is the extension in X. Okay, and for metal Y to extend by 1 millimeter. Okay, the same load is then hung from a second wire of same cross-sectional area consisting of 1 meter of metal X. So here we have X and 3 meters of Y. Okay. Both the wires extended within their limit of proportionality. What is the total extension in the second wire? Okay. Now the main thing here in the question is the Young's modulus in both the situation for these individual wires will remain same, right? Also, we have to assume that the stretch or the stretching force, tensile force, is same throughout. In both the cases, right? Now we know that Young's modulus equals to tensile force divided by area of cross section, and the strain is extension per unit original length, right? Now if I write the value for X, for the wire X, the tensile force is F divided by A. The stretch in the length of X is 1.5 millimeters and the corresponding length of X is 3. Okay. Similarly, if I write for wire Y, that is force per unit area, that ratio is same, stress is same. The extension in Y, so that is 1 millimeter divided by the original length, 1 meter, right? So it is in millimeters, millimeter, it is in meter, it is in meter. Okay. Now, if we look at the second case, this value for yx, that will remain same. He is saying that the tensile force and area of cross section is same, but in the second case he is stating that the value of x is 1 meter. So here we have 1 meter, and the corresponding extension in x we have to calculate, because we have to calculate the overall extension in this second formation. So we will write F by A. The corresponding length is 3 meters divided by the extension that is produced in the second case. Now if you solve this, you will get delta Lx equals this, and this would cancel. So that is 1.5 divided by 3. So that is 0.5 millimeters. Similarly, if you look for the extension in y, so that is 3 millimeters. So the total extension will be the sum of both these values, 3 millimeter and 0.5 millimeter. So that is 3.5 millimeters. So the correct option is option B. So in question 24, the graph shows the variation of the displacement with distance for a progressive wave at one instant in the time. So it is the graph between the displacement and the distance. The period of the wave is 91 milliseconds. What can be determined about the wave? So if we just look at the graph, so this displacement means what? Displacement of the oscillating particle. Because it's a mechanical wave, this distance is the distance traveled by the wave. Okay, so this distance is traveled by the wave. So if you look at here, so the wavelength of the wave is 4 centimeters. So that is 4 into 10 to the power 2 meters. Okay, and the frequency can be determined from here. So frequency equals 1 by the time period. So that is 1 by 91 milliseconds. So that is equal to 1000 divided by 91 hertz. So from here, what information we can get? Let's check for the velocity. Velocity is frequency times wavelength. Frequency we have 4 into 10 to the power frequency is 1000 divided by 91, and the wavelength is 4 into 10 to the power minus 2. So from here we have 40 divided by 91. So if we solve it, we will get 0.44 meter per second. Okay, so this appears to be okay, and the frequency is 11 hertz. So if we solve this, so it comes out to be 10.98. So that is about 11 hertz. For two decimal places, it is 11 hertz. So A is the correct option. So this is a simple fact-based question. So in this question, he is asking which group of electromagnetic waves is arranged in order from the shortest wavelength to the longest wavelength. So for X-rays, we know that it is about 1 angstrom. So this is 7000 angstrom. So it is increasing wavelength from the shortest to the longest we have to write. So the correct option is option D. 26th, a wave has a frequency of 5 gigahertz. What is the period of the wave? So the time period is 1 by frequency. So that is 1 by 5 gigahertz. So what is 1 gigahertz? What's the value of 1 giga? So that is 5 into 10 to the power 9 hertz. So if we solve this, this is 1 by 5, that is 10 to the power minus 9. So that is how much? That is 0.2 into 10 to the power minus 9 seconds. So if we look at the options, so this you can write 2 into 10 to the power minus 10 seconds. So nothing is matching. Okay, pico means 10 to the power minus 12. So you will have to add 2 zeros, 10 to the power minus 12 second. So that is 200 picoseconds, right? So A is the correct option. Question 27th is the question on waves. Three statements about two progressive waves are listed. The waves have the same frequency, the waves have the same amplitude, the waves are emitted with a constant phase difference. Which statements must be correct for the two waves to be coherent? So for the two waves to be coherent, they must have the same frequency and they must maintain a constant phase difference. So the correct option is option C. Question number 28. Waves P and Q have the same amplitudes. Same amplitude means they have the same intensity. Let I naught is the intensity of each wave. The waves meet in phase at point X. They are meeting in phase and interfere to give a resultant intensity I. Okay, let's write it. I will be equal to I naught plus 2 under the root I naught cos of 0 degree. So that will give us 4 I naught. Okay. The amplitude of the wave P is double. Now we are increasing the amplitude of wave P. What is the new intensity of the resultant wave at X in terms of P? Okay. Now we are increasing the amplitude to twice, and we know that the intensity is proportional to the square of the amplitude. So this means now the intensity of P is becoming equal to 4I naught. So the new intensity, let it is I dash. The intensity of P is 4I naught. Intensity of Q will remain same, 2 4I naught into I naught, and that is cos 0 because they are adding in same phase. So that is 5I naught plus 2. So this under root 2 will give us 2I naught. So that is 4I naught. So finally we'll get 9I naught. Okay. Now we have to calculate I dash in terms of I. So divide both of them, I dash by I. So that is 9 by 4. So that is 2.25. So if we want to write in two decimal places, so that is 2.3 I. Okay, so the new intensity is 2.3 times I. So option is C. Question number 29. Radio waves can be polarized, but sound waves cannot be polarized. So this is a very simple question because radio waves are transverse waves and the sound waves are the longitudinal waves. So we have to check for the options. So A, radio waves are generally of higher frequency than the sound. So it is of no use. This information has nothing to do. Radio waves are transverse waves, but sound waves are longitudinal. Yes, B is the correct option. Light wave of wavelength lambda is incident normally on a diffraction grating with a total of n lines in the width W. Okay. A second order maxima is observed at an angle of diffraction theta. So what's the value of n? Okay. Now from the theory of diffraction, we know that d sine theta, that is equal to n lambda. So what is d? D is the slit size. For the single slit I am writing. N is the order. So we are given with the second order. So that is 2 lambda. Now this is sine theta, but we don't know that what is the size of a single slit. So how many slits are there? There are n lines, means n slits, and over a width W. So for a single line, the size is say D, and we will divide the total width by the number of lines. So that will give us the size of a single slit. So from here we can write W by N, and we have to calculate the value of N. So that N will be W sine theta divided by 2 lambda. So the correct option is option C. 31st question. Kirchhoff's second rule is a consequence of a basic principle. Yes. What is this principle? So basically it is simple, very simple. It is based on the conservation of energy. So the energy in an electrical circuit is conserved. Right. B is the correct option. Question 32. The diagram shows a circuit with light dependent resistors. Okay, so here we have an LDR. The ammeter reads zero current. Okay, so the current in the ammeter is 0. what is the resistance of LDR? This means if the current here is 0 and you are applying a 12 volt battery, this means this is forming a Wheatstone bridge. So in the Wheatstone bridge arrangement, you can write 6 kilo ohm divided by R, that is equal to 10 kilo ohm divided by 30 kilo ohm. So if we solve this, we will simply get 18 kilo ohm. So the right option is option B. Question 33. We have a torch that uses 3 lamps connected in parallel and is powered by a cell of EMF 3 volts and negligible internal resistance. Each lamp dissipates 0.6 watt of the power. What is the current in the cell? So as the 3 lamps are in parallel, so this is lamp 1, lamp 2, lamp 3, and each lamp is drawing a current I, suppose, and each bulb is dissipating 0.60 watt. So the total power consumption by the circuit is 0.6 times 3, so that is 1.8 watt. Okay, now the EMF of the battery is 3 volt, so power is equal to voltage times current. Okay, so that is the total current. So the total current is 1.8 watt divided by the EMF, so that will give you 0.60 amps. So the correct option is option C. Question 34. A cell with internal resistance is connected to an LDR, a fixed resistor, and a voltmeter as shown. Okay. The voltmeter reading increases, means the reading of this voltmeter is increasing. This means the current that is flowing in this situation will increase. Now, how the current will increase? For the current to increase, the resistance of this LDR has to decrease. The resistance of this LDR is decreasing. Okay. Now, he is asking that which quantity decreases as the voltmeter reading increases. Its reading is increasing. We have to check that which values are decreasing. Option A is saying the charge moving through the cell per unit time. Now that is the current, but the current is increasing. The energy transferred to the fixed resistor per unit charge. Now what is the energy transferred to the fixed resistor per unit charge? That is the voltage. So this is also wrong. The intensity of the light incident on the LDR. This is also increasing because the resistance is decreasing. So that is as per the principle of LDR. Fourth option, the terminal potential difference across the cell. This is decreasing. So let's check this. So the terminal voltage across the battery is say Vt, that is equal to E minus IR. Okay, now as the current is increasing, so this product will increase, so that will lead to decrease in the terminal voltage. Okay, then D option is the correct option. Also we have inferred that D will be right because all other 3 options are wrong. So you can do the questions in that way also. You can stroke off other options to get the right option. So this is called the elimination procedure. The circuit shown contains a cell with negligible internal resistance, right? The energy transferred per unit charge in driving charge around the complete circuit is E. Okay. The difference, the potential difference across X is V, right? So what is this energy transfer per unit charge in driving the force? So that is basically the ability of the battery. So you can say that it is EMF. The cell is then replaced with a different cell of the same electromotive force. Means the ability to drive the charge in the circuit is same. And that has now the significant internal resistance. Earlier it has no internal resistance. See, no internal resistance. What is the effect of E, effect on E and V for replacing the cell? So E will not change, that will remain same, but for V, as the internal resistance has increased, so the value of the current in the circuit will decrease, and the product of the current and the resistance will decrease. That is the potential difference across X, so that will decrease. So the correct option is option C. There is no effect on E and V will decrease, right? Question number 36. In the circuits shown, the batteries are identical and all have negligible internal resistance. All the resistors have the same resistance. Okay. The diodes have zero resistance when conducting and infinite resistance when non-conducting. In which circuit is the current in the battery greatest? Okay, so if we look carefully on all the circuits, we have to find that in which situation the resistance of the network is minimum. Now for minimum resistance, you have to look for the parallel arrangement. So this will not work. So we are only left with options A, C and D. Now in option D, you can see that here the bias is reverse. So this is offering an infinite resistance. In this situation, this is again an infinite resistance. But if you look at option A, so here the resistance is 0, resistance is 0, the resistance is R, resistance is R, suppose. So the total resistance is the least resistance R by 2. So in option A, the current is maximum. So you have to look for the situation in which the circuit is offering the least resistance, right? Now this question number 37 is the question on potentiometer. So here he is saying that a potentiometer circuit is used to determine the EMF of a cell. So we have to determine the EMF of this cell. The circuit includes a second cell of EMF 1.5 volt. Here it is, and internal resistance of 0.5 ohm. That is connected to a uniform resistance XY. Okay. Now this uniform resistance has a length 0.96 meters and it has a resistance of 0.5 ohm. The resistance wire XY has a length 0.96 meter and resistance 0.5. Same it is given here. The movable connection Z is moved along wire XY. The galvanometer reading is 0. This means we have achieved the balancing length, and the balancing length is 0.64 meters. Okay. And what is the value of EMF E? You have to calculate the value of the EMF here. So for this, you have to calculate that what is the potential drop between points X and Z. For that, you need to calculate the current in the circuit, right? Now, in order to calculate the current in the circuit, we use the formula I, that is the EMF of the cell, 1.5 E divided by the resistance of wire XY, that is the external resistor to this arrangement, plus the internal resistance. So the resistance of XY wire is 0.5. So 0.5 plus 0.5, so that is 1. So the current here is 1.5 amperes. Okay. Now when this much current is flowing through the circuit, then you have to calculate the resistance of this wire XZ, and if you multiply this resistance with this current, you will get the potential drop across this. Now we know that the resistance per unit length of the given wire is this much, and that will remain same. So the resistance of wire XZ divided by the length of the wire is 0.64. So from here we can calculate the resistance of wire XZ. So that is 0.50, that is 0.64 divided by 0.96. If you solve this, you will get 0.33 ohm. So the voltage drop across XZ will be 1.3 ampere times 0.33 ohm. So if you solve this, you will finally get 0.50 volt. So the correct option is option A. Question number 38, that is purely fact-based question. He is asking that which particle is not a fundamental particle. So neutron is not a fundamental particle. It is made up of quarks. So it is not a fundamental particle. Question number 39, the isotope fluorine 18 undergoes positive beta decay to form a stable isotope. So how many neutrons are there in a nucleus of stable isotope? So for that, first write the equation. So that gives you a new element plus with a positron. So you will write it like that. So using the conservation of charge, we can write this equation. So what is 18? That is the mass number. That is the proton number. So the neutron number is mass number minus proton number. So 18 minus 8, so that will give you 10. The correct option is D. Which statement is correct? So in 40th question, you have to tell that which question is correct. Option A, a baron is a hadron and consists of 2 quarks. Wrong, it consists of 3 quarks. Okay. A meson is a hadron and consists of 3 quarks. This is again wrong. It consists of a quark and an antiquark. So it's a combination of these two. An electron is a fundamental particle and is a lepton. Yes, this is the correct option.